All right, welcome to lesson 2.3.5. Let's start off with part D, or reading the instructions for part D. It says, graph the solution set for each system of linear inequalities. Label all points of intersection of the boundary lines. Then determine a point that satisfies all of the linear inequalities in the system. Okay, so for number one, we are given three equations. So we're going to graph all three inequalities, and we're going to shade them in, and then we're going to find their points of solutions. Okay, so for the first equation, I actually want us to do this one. Like, I want us to answer this one first, just because this one is a little bit more difficult because x and y are on the same side of the inequality. Notice that for the first and the last inequality, y is by itself, making it easier to graph and shade. But for the middle equation, x and y are on the same side. They're right there on the same side of the inequality symbol. So it's going to make it a little bit harder for us to graph. So I'm going to graph that one first. Okay. So for this one, when it's in the x and y are on the same side, that's called standard form. And so when we have an equation in standard form, it makes it a lot easier for us to graph it by solving for the x-intercept and then solving for the y-intercept. So to solve for the x-intercept, you're just going to focus on the 3x and the 6. You're going to ignore the y because we're looking for the x-intercept. So I'm going to look at the 3x and I'm going to set it equal to 6. So where did I get the 3x from is right here, and where did I get the 6 from is right here. We're looking for our x-intercept. Now, to get x by itself, I'm just going to divide by 3, and that gives us x is equal to 2. That means I'm going to put a dot right over there. I'm making it pretty big so it's obvious, but that is our x-intercept. Notice that it's on the x-axis, so I put my x-intercept at 2. Okay, I'm making the dot a little bit less obnoxious now. Let's find our y-intercept. So in order to find the y-intercept, let me erase those underlines. Okay, so to focus on the y-intercept, we're going to take a look at the negative 2y, and we're going to set that equal to 6 again. And then we want to get our y by itself. So when we ignore the x part, we will solve for our y-intercept. So let's solve. We're going to divide by negative 2 on both sides. That will cancel out the negative 2 that was being multiplied to y. So you cancel out multiplication by division. That's why we do that. We end up with y is equal to negative 3. So this is our y-axis. So I'm going to go over to negative 3 and I'm going to put a dot. And so there we have 2 dots, and if we connect our 2 dots, we will be able to get our line. So before we connect them, do we want this to have a dotted line or a solid line? Look at our inequality symbol. Our inequality symbol says greater than or equal to, specifically because there is this line underneath it, greater than or equal to. That equal to says we have to use a solid line. So I'm going to go ahead and put a solid line between those 2 dots. Okay, so here's my solid line. And now, because this is an inequality, I need to know whether I want to shade on top or on bottom. So in order to figure out if I want to shade on top or on bottom, we are going to test out a point. I'm going to test out, you can test out any point. Like I could test out over here 2, 9 if I wanted to. But I think the easiest thing to test out is always 0, 0. So I'm going to test out 0, 0. Let me write that here, test 0, 0. And so we're plugging it into this equation. 3x minus 2y is greater than or equal to 6. And we need to see if this gives us a true statement or a false statement. So let's take a look. I'm going to plug it in now. So 3x, well, in our test point 0, 0, x is 0, minus 2y, well, that's going to be a 0 as well, is greater than or equal to 6. Let's see if this is true. 3 times 0 is 0, and then 2 times 0 is also 0. And then 0 minus 0 is still 0. Do you see how when you plug in 0, 0, it's easier than if you had to like actually multiply numbers? 0, 0 is just the easiest point to test out. So in the end, when we simplified, we got 0 is greater than or equal to 6. This is a lie, because 0 is not greater than or equal to 6. 0 is much less than 6. So since 0, 0 is a lie point, we don't want to shade this section where 0, 0 is in. The section that 0, 0 is in is wrong. So we must shade the bottom part. Shade the side that 0, 0 is not a part of. So I'm just going to shade that in. Okay, there we go. So I've shaded that bottom half where 0, 0 is not a part of it, because 0, 0, remember, told us a lie. So if 0, 0 tells us a lie, then you go away from it. If 0, 0 told us the truth, then you would shade the section with 0, 0, but only if it tells us the truth. And in this case, 0, 0 lied to us, so we want to avoid it. So that was one equation that we graphed. Now let's graph the other two. So I'm going to graph this first one, and I'm going to graph it in blue. So this one says y is greater than or equal to -3. This is very straightforward, because take a look at how easy it is. Y is greater than or equal to -3. Well, we're talking about the y-axis here, so I'm going to go to -3, which is this point right over here. Can you see me marking it in blue? Let me just point to it. That point. So that is the -3, and then we're going to draw a horizontal line straight across. Also, before I draw it, should it be a dotted line or a solid line? According to our symbol, this should be a solid line, because it has the greater than or equal to symbol. Because of that line underneath, that means it's solid. So I'm going to draw a solid horizontal line straight across. So this is my line for that graph. And of course, we need to do some shading. So when we're shading it, do you want to shade above or below? So in this case, it says y is greater than or equal to. So specifically, we're looking at the greater than part. So since it says y is greater than, you want to shade above. So I'm going to shade everything above because it says greater than. All right, so shading takes a little bit of time, but I'm sure it takes you some time to shade as well. So it's all good. We're just taking our time to shade. Shading. Okay, so you might notice there is some overlap now. There's a little green section that got shaded by the blue and the yellow. That's great. We'll see what ends up happening once we graph our third equation, or our third inequality, I mean. So let's take a look at our third inequality, and for that one, I shall shade it in purple. So this one's going to be done in purple. This says y is less than -x plus 2. This is in slope-intercept form. So that means we have a y-intercept at 2. So I'm going to go over to our y-axis at 2, and I'm going to put a dot there. And then we have a slope of -1, which means our rise over run is -1 over 1. And how is it -1 over 1? Well, if our slope is -1, -1 divided by 1 is still -1. So anytime you see a whole number as our slope, it's over 1. Okay, you have to put it over the number 1, because anything divided by 1 is itself. So therefore, our rise over run is -1 over 1, which means from our original y-intercept at 2, we're going to go down 1 and then right 1. Down 1, right 1, down 1, right 1, and keep going. So down 1, right 1, all the way until the bottom. And so from here, we need to connect it with a line. So do we want to connect it with a dotted line, or do we want to connect it with a solid line? So in order to figure that out, we want to take a look at our symbol. This is y is less than. I do not see the equal to line. And because we do not see the equal to line, that means this is a dotted line. So I'm going to connect all of these dots with a dotted line as best as I can. Very sloppily, kind of, but we do the best we can with our iPad. Sorry, with my iPad, I'm trying. Okay, so there's my dotted line. Sorry, it's a little bit crooked, but I did my best. Last but not least, we need to shade. So, do we shade above or do we shade below? This says y is less than. So if it says y is less than, then we want to shade below. So let me go get my shading and let's shade below. Everything below that purple line. And by the way, when we are shading, or when I say the less than tells us to shade below, we can do that only when y is by itself in the equation. So you know how when we when we graphed that yellow equation, I told you it's difficult and I told you we needed to use a test point. So I couldn't just say, oh, it says greater than, that means we shade above, because in the yellow equation, x and y are on the same side. Y is not by itself. So you can't just shade above and below unless y is by itself. So in the case of the yellow equation where x and y were on the same side of the equation, like I'm literally going to circle it right here. X and y are on the same side of the equation. You cannot just say, oh, it says greater than, I'm going to shade above. Because take a look at where we actually shaded. We shaded below that black line. Okay, so it's a little bit different. So when you have x and y on the same side, you're going to use a test point. If y is by itself, then greater than means shade above and less than means shade below. I'm going to write that down in words actually, so that way you guys won't forget. If x and y are on the same side, just like in our yellow equation, okay? On the same side meaning like, look at our yellow equation. Then you use a test point to see where to shade. If y is by itself, such as in our blue equation and the purple equation, so the second and third equations that we did, like this one and this one, when y is by itself, then greater than means shade above, and less than means shade below. Okay, so in our blue equation, it said y is greater than. That means you shade above. In our purple equation, it said y is less than, so we shaded below. Okay, so hopefully you can pause the video so you can write this down on your own time. Hopefully you got it down, and let's continue to follow the instructions. So the instructions said to graph the solution set for each system of linear inequalities. We did that. We now need to label all points of intersection of the boundary lines. Okay, let's do that one, and I'm going to write our boundary line intersections in black. So where do our lines intersect? Well, we have a point over here where the purple and the black line cross over, and that is 2, 0. Okay, and then we also have another intersection right over here where the blue and the purple cross over. That is 5, -3. And then we have one more point where the blue and the black cross over, and that is at 0, -3. Remember, always put your x first and then the y afterwards. And then finally, we must determine a point that satisfies all of the linear inequalities in the system. So what that means is, where did all of our shading intersect? They intersected on the inside of this little triangle. So we can pick any point from inside this triangle as our solution that satisfies the linear inequalities in the system. So you can pick any point in there. I'm just going to pick this one just because it's like in the middle of it. And I will label it over there because that's where I have space. And that one is 2, -2. So once again, you could have picked anything inside that triangle, but I just picked that point because it's the most obvious point that's in the middle of it. All right, so that was it for number 1. I know I said that was it, but that was a long recording, but it's just, once you get the hang of it, it will be faster. So the more you practice, the faster it gets. And I was talking a lot, so when you're doing it on your own, hopefully it'll be faster. Let's take a look at number 2. So for number 2, we have y is less than or equal to 3, y is greater than or equal to -5, y is greater than -2x plus 1, and -2x minus 3 is less than y. So this one's actually in reverse order, so I'm going to rewrite this. Y is greater than -2x minus 3. So I want to have y first. Otherwise, what I said over here, it doesn't apply unless y has to be first. So y has to be on the left side of the equation. Okay, or technically inequality. Y should be on the left of the inequality. Let me fix that. Y is on the left of the inequality. Okay, there we go. So as long as y is on the left side, then if it says greater than, you shade above. And if it says less than, then you shade below. Okay, so let's take a look. Are any of them in standard form? Like our yellow equation over here in number 1? I don't see anything in standard form because in all of these inequalities, y is by itself. So we have slope-intercept form and we have some horizontal lines. So that's good. Let's start off with, I guess, this one. Y is less than or equal to 3. So like I said, this one's pretty straightforward. You just go to 3 on our y-axis, and then we can draw a horizontal line there. So do I want to draw a dotted or do I want to draw a solid line? Take a look at our symbol. It says less than or equal to. Because it has the equal to line, I can draw a solid line connecting drawing a solid horizontal line through that point. There we go. So now that we have our solid line, it says y is less than. And so we're going to shade below because it says less than. Okay, so I'm going to shade everything below here. Okay, I'm going to try to be a little bit less of a perfectionist and just shade it in because it takes a while. Okay, so here we are shading it below. And then let's take a look at y is greater than or equal to -5, our next equation. And I'll do that one in, let's do purple. Or sorry, let's do green. Okay, y is greater than or equal to -5. So going down to -5, putting a dot there. And do we want a solid line or a dotted line? So take a look at the symbol again. It says greater than or equal to. I see the equal to line, which means we're going to connect it with a solid line. So solid line through that spot. There we go. And then it says y is greater than. So because it's greater, then that means you shade above. So greater means shade above. So I'm going to shade above. Oops, my bad. There we go. I don't know how I accidentally scrolled. Okay. Shade, shade, shade. Hurry up, Miss Jade. Oh man, we've got some double shading there, but it's okay. All right, so we shaded above because it says y is greater than or equal to -5. All right, let's go to another equation. So I already used purple and green. Let's do yellow. Okay, y is greater than -2x plus 1. So this is in slope-intercept form. So let's take a look at our y-intercept. And I'm going to use black to graph our yellow line just because black's easier to see. So our y-intercept is right over here, the 1. So I'm going to go over to 1 and put a dot. And then it says our slope is -2. So remember, when your slope is -2, technically that's -2 over 1, which means your rise is -2 and your run is 1. So that means from our y-intercept of 1, we want to go down 2 and right 1. Down 2, right 1, down 2, right 1, down 2, right 1, and just keep going. And I'm going to follow that same pattern in the opposite direction. There we go. Okay, so I have all these dots now. Do I want to connect it with a solid line or a dotted line? Take a look at our symbol. It says y is greater than. I do not see the equal to line underneath it, so that means we must use a dotted line. So I'm going to connect everything with a dotted line. Okay. So here I have my dotted line, and I must figure out, do I shade above or below? So it says y is by itself, so we're good. Y is on the left side of the inequality, so we're good. We can take a look. Does it say greater than or less than? It says y is greater than, which means you shade above. So put your shader or whatever you have, pencil, mouse, whatever, on the graph and go up so you can see that the above side is the right side. And so I'm going to shade everything above, which is also technically to the right. So shading everything into the right side. I know your entire graph has shading on it, but yep. Okay, and then we only have one more inequality to shade. Oh, by the way, let me show you guys how I would shade it if I was shading on a piece of paper. Because I feel like if you're just shading in with your pencil in only black pencils, like if you don't have color, this is gonna get really messy, right? So let me show you how I shade it if I didn't have a highlighter to shade. So let's say for my green, I shaded above, so I would go like this. Can you see it? I would just literally like make shading marks like this. So it does get a little bit messier than if you had a highlighter. So if you have a highlighter and you're doing it on a piece of paper, that's good. If you're doing it on Cami, I'm not sure, but I think they have a highlighter function, so you could probably use that. So this is me shading above for the green. For the purple shading down, I would have done this. Gone the opposite direction. Now I know it does look messier, but that's kind of what happens when you shade everything on your entire graph. But I just wanted to show you guys what you could do if you weren't using highlighters. And then for the black / yellow, I would have gone like this. Now I know this looks terribly messy, and I'm apologizing for that ahead of time, but this is kind of what happens when you shade a lot. So just don't like scribble everything in, because then that gets really even messier. So hopefully something that you're doing will work. Either you're shading it like with the marks, or you're just highlighting it, or whatever works for you. Do whatever works. Let's do our last equation. Okay, so our last equation is y is greater than -2x minus 3. And so once again, we have our y-intercept right over here, the -3. Let's put our dot over there. And then we have our slope of -2. And so we kind of already had a slope that was -2 earlier. So we can use that same work we did earlier. -2 is the same as -2 over 1, which means you're going down 2 and right 1. So go down 2 and right 1. and just follow that same pattern in both directions. Okay, and then once we do that, let's take a look at our symbol. Does our symbol want us with a dotted line or a solid line? And if you look at here, if you don't see the equal to line, then it must be dotted. So I'm going to connect it with a dotted line. All right, so here's my dotted line that goes through. And it says y is greater than, which means I'm going to shade above. So I'm going to first highlight it to shade above. This section is above our line. I know there's so much going on in this picture, I apologize. Okay, so that entire section is above our blue dotted line. And so how would I shade this one in with a pen? If I had a pen, then I would just kind of go like this. Kind of like with horizontal lines to the right side. Oh my gosh, that is a lot of shading. Okay, so then you have to ask yourself, which part got shaded by all four? So I know it's hard to see, but I'm going to highlight in black now. It's actually this section in the middle that got shaded by all four. Okay, so I'm just highlighting it in black so it's a little bit easier to see. Maybe if you were actually using a pencil and paper, it would be easier. I don't actually know. It's been a long time since I wrote on a pencil and paper. So that inside like parallelogram shaped thing is where all of our shadings overlapped. Kind of like how we had a triangle in number 1, now we have a parallelogram in number 2. So we're going to label all points of intersection of the boundary lines. So I see a point right here, that is -3, 3. I see a point over here, that is -1, 1, 2, 3. See a point over here, that is 1, -3. And I see a point over here. Sorry, it took me a while to be able to point. It lagged a little bit. So that point is 3, -3. Cool, so we have all 4 intersection points labeled. And then we're going to determine a point that satisfies all of the linear inequalities in the system. So pick any point that's inside your shaded region. So you could pick 0, 0, or you could pick 0, -2, or you could pick -1, 0, or you could pick -1, 1. It's up to you. Anything that's inside that shaded area, you can pick. I'm just going to choose 0, 0 because it's easiest to write. I don't know. Because I like 0, 0. I like the origin. So that's a point that satisfies all of the linear inequalities in the system. Okay, so that was our 2 examples for this section. And then for your homework or rest of class time, you guys are doing the skills practice part D 1 through 6. So it's only 6 problems that are like this. I know they take a longer time. That's why there's only 6 of them. All right, so you have 6 problems to do like this. You graph all of them. And you label your points of intersection and you determine a point that satisfies all of the linear inequalities in the system. So if you have any questions, please call me over into your breakout room so that I can help you out, okay? I'm gonna see you guys in the next video or see you guys later.